Welcome back. I'm Alan Hall.
I'm Dan Blewett, and this is the UPTIME podcast, where we talk about wind energy, engineering, lightning protection, and ways to keep your wind turbines running. All right, welcome back to the UPTIME podcast. I'm Dan Blewett, and I'm joined here remotely by lightning protection expert Alan Hall. Alan, how are you?
Great, Dan. Another busy week. A lot of things in the news. What do you got at the top of the list?
Well, so today in our episode, we're going to talk about the patent dispute between GE and Siemens Gamesa Renewable Energy. There's some interesting news about new testing facilities potentially opening up in the future. We're going to talk about a pretty interesting wind prototype that could potentially handle typhoon winds. And lastly, we're going to talk a bunch about Dinotails and their inspiration from the owl, which owls are just such awesome creatures. They're just amazing. But anyway, Dinotails are pretty interesting. They reduce the noise and of obviously turbine blades create a lot of noise. They're slicing through the air so fast. And if they reduce this noise, then they can potentially operate at higher speeds and still be in compliance with local laws. So we'll chat a little bit about that. So yeah, it's been busy, Alan. How are things up there in Massachusetts?
It's summertime. We're trudging along. Took a little ride up to Vermont. Check out some of the wind turbine sites up there. There's a number of wind turbine sites that have been added in the last 5 years, I'd say. So there's a lot of different varieties of wind turbines locally and obviously even across the United States. Pretty much within an hour's drive or so, you're going to be able to find wind turbines in the States. It's a very active marketplace right now.
What are the biggest sizes up by you? You see a pretty wide range, or are they all pretty steady?
About 45 meter, 50 meter blades is about the biggest we see up here. I think that's a factor of just the weather, the winter conditions tend to limit that, and the mountaintop rural locations that these get installed in.
Yeah, gotcha. So speaking of high market share in the U.S., GE, which is I think still number one, or they're getting maybe caught by Vestas in the U.S. GE is defending their one of their licensing agreements with other turbine companies. So they're in a dispute between Siemens Gamesa, and this looks like it's going to get a little bit testy. What's your take on the lawsuit between GE and Siemens Gamesa?
Well, clearly GE has a patent, and it seems like Gamesa, at least in theory, I know both sides are going to dispute this, is in violation of that patent. So the way this plays out is wherever you have patent protection, you can defend that patent. And it's just make it real simple here. So if GE, being a U.S.-based company, wants to enforce their patent on U.S. territory, that means Siemens Gamesa pretty much can't offer that technology in the United States. Or if they do, they can, GE can go all the way and try to get some sort of embargo or stop the shipments from happening, and then impose fines, ask the federal government to impose fines, and it can get ugly fast, especially when you got big players. And both sides have attorneys, I'm sure several attorneys firms locked up in this.
Yeah.
They have armies of attorneys, unlike small businesses which just can't afford that. GE and Siemens Gamesa totally can, so they can go to legal battle for a long time. The problem is, at least in the United States, the companies have learned that if they bring the federal government in to act on their behalf and to enforce these patent rulings, that it puts a real financial strain on the other company. So you don't really have to win the argument. You just have to get the federal government to sort of back your side. And when you got a U.S.-based company and a international company coming together, well, you know how the U.S. is going to go on that. So it just creates these impediments for business to happen, and it doesn't make a lot of sense to let those go on. The best for both sides is just to negotiate it and come to agreement, and somebody pays somebody else and move on. I think that's eventually where it's going to get to. But being in this sort of economic environment we're in, that may not be as easy as it seems, because that's the way it's mostly played out. If you've watched Microsoft or some of these software companies get involved in lawsuits for patent infringement, Apple being another one, they can trudge on for years. And finally, they just involve the federal government and try to put the hammer down. That's where it starts to make a turn. So GE could probably use a little bit of help right now, honestly, just because their stock price is so low, and financial strain that they're in, they're going to take this one to the mat probably.
Yeah, well, they say almost all of Siemens Gamesa's U.S. turbines are in infringement, according to the complaint. So, yeah, they're going to take a good chunk of change off them if they can continue to get either royalties or whatever the agreement ends up being. So, yeah, and GE's definitely hurting. Yeah.
Yeah, if you happen to own those wind turbines in the States, you don't want to be in that situation where GE can, in theory, start fining you or shut you down, and that's just bad. It's just bad for the industry as a whole. You don't want to see those two duke it out at the local level. That will be no fun for anybody. So it's better resolved across a conference room table somewhere. But it doesn't seem like that's going to happen immediately. At least reading the recent articles about it.
Yeah, so let's shift a little bit. Obviously, we've talked a bunch about testing and lightning standards, and lightning standards are pretty lax, especially according to some companies like DNVGL, who are pushing for, more rigorous standards with which to certify things. But this article from Wind Power Engineering is talking about it. There's a new blade testing center opened in 2017, and some of these older standards in 2014 are getting pretty outdated because blades have become just so huge in such a short period of time. I mean, even in 6 years, they've really grown. So you've done lightning testing extensively in the aerospace industry. Yeah. What are the challenges behind getting a new, up-to-date facility of this size?
Well, they got a couple of problems. Anytime you're trying to keep up with industry, in terms of the size of anything, in this particular case, as the wind turbines start to incorporate more and more carbon fiber, the strength of the carbon fiber allows the blades to get longer and longer and wider. So from a structural standpoint, you need a facility to handle that. And that's hard to come by because those facilities don't get used all that often. But when they need to get used, and they got to keep up with the current rate of technology, and the infrastructure investment is really left up to the local or state or federal governments across the world to support this stuff, because there's really no private investments going to be able to keep up with the rate of advancement that these blades are making. So on the lightning side, as we've seen with some of the lightning test facilities around the world, as we've been testing longer and longer sections of blades, the facilities have gotten bigger and bigger and bigger. In the United States, Lightning Technologies, which is now NTS, several years ago built a fairly large high voltage test facility. But even now, that's still, you kind of press the limits there on its size where the blades continue to grow. Polytech over in Denmark has a very large lightning facility. But on the structural side, you're testing essentially full-length blades, and you're trying to put mechanical stresses and sort of lifetime test these blades by pulling, pushing, twisting, trying to put wind loads on them without actually wind loading them. So you got to create this mechanical environment where you can stress these things. Just imagine, so these blades are laying on their sides, so you got to have just basically a huge amount of concrete and a mount on one end. And you can mount the blade up to horizontally, and then the blade's running across the facility, and then you got to hook actuators and hydraulic actuators that pull, twist, move in a manner that simulates use on an actual wind turbine somewhere. That's not easy to do. It takes a lot of computer technology and a lot of engineering just to simulate those loads and to predict those loads, and then to apply them is just a whole nother level. But as this little article talks about, what does it say, Dan? Is it 1 in 200 blades fail a year, like 0.5%?
It's just crazy.
That's a large number, because there are a lot of wind turbine blades out in the world. Now, fail, as we were discussing earlier, fail can mean anything from fall off, hit the ground, to have some sort of mechanical failure where the blade buckles or splits or something of the sort. So it doesn't necessarily mean huge catastrophic, but 1 in 200 is still expensive. So is that number really correct? And if it is correct, then the mechanical testing that happens at these facilities really needs to be ramped up, enforced, verified, validated. Because one of your biggest problems is you can predict what the outside world looks like mechanically, but you never really know until you get out there and you watch how some of the failures are occurring, and then the engineers stumble around and try to figure out what has happened to these broken blades, and then incorporate it into some sort of usually a company test standard, which gets applied at these test facilities. So it's like a constant control loop of design the blade the best you can, do some testing on it, limited testing on it, make sure it doesn't really want to come apart, put it out in the field and watch it. And if it does come apart, then you get back in that loop again where you're coming back and trying to evaluate why that happened and how you're going to test it so you can validate the next series. So it's not the easiest thing in the world to do. And every part of this is really, really expensive. Millions and millions and millions of dollars for these facilities. And it's just hard. No way we're getting around it. It's just hard.
Well, and I guess as you're talking, I'm thinking, why don't some of the companies, like the big players, like the Siemens Gamesa, the GE, I mean, is there a way for them to all sort of share the burden and create an independent lab that they fund? Maybe they all back a major university, like this is, university in Denmark, but
right. DTU.
Why isn't there some collaborative effort like that?
There is in some level. Like the state of Massachusetts, where I'm at, has a wind turbine test facility, blade test facility, near the ocean. Actually, they built that a couple of years ago, and I'm sure it's outdated already. But there's not well, I guess in Rhode Island there's a blade manufacturing facility. TPI is down in Rhode Island, so somewhere close is a blade manufacturing facility. But yeah, you're going to need to have investment. And I think the way that the local governments, at least in the United States, look at it as if they put those facilities in their states to do the testing, that kind of means you need to be doing either engineering and manufacturing for blades in your state. Like you make it a reasonable place to put your plant. So sometimes the test facilities land first, and then to encourage the manufacturers to come there later. It's hard to make them pay for that up front, but you are making them pay for testing. There's no doubt about that. If you're going to be occupying that facility for 100 days, you're going to pay for 100 days of test time, and that will not be cheap. But if you can think about it, I would be hard pressed to think that those facilities are used 50% of the time, 70% of the time. Most lightning labs and structural test labs on smaller components are busy, but there's not always one. They're not 100% busy all the time. It's just not the way things work.
All right, well, we're going to jump to our engineering segment. And first thing on our docket today is the Enercon E115 EP3. So this is a wind turbine that just had its first successful installation in Belgium. And this is interesting because they said it can take wind up to 89 meters per second, which is about typhoon speeds.
Yeah.
And this seems pretty crazy. I mean, we talked about the Typhoon turbine, which is literally called the Typhoon turbine by a different company back in an earlier episode of the show. And but this is like a pretty standard design. This isn't, this looks like a normal wind turbine. But what do you think the technology is here that's going to help this withstand such high speed without breaking apart? I mean, what do they have to bolster?
Tower, blades, the cell. Pad,
just all of it, just all of it.
Yeah, I think it's going to be all of it because that's one thing about any sort of strong winds. Like it's hurricane season in the United States, and so we're starting to have hurricanes pop up on the southeastern coast. Is those winds swirl, right? So you really can't tell what direction they're going to come from necessarily, and you got to be able to take just the total wind load on the towers and the blades and everything else, and transfer that load into the ground, and not have the whole thing just topple over. That's not easy to do. So probably every single component of the structure is going to have enhancements to withstand these things. More than likely, this type of wind turbines obviously is just going to be used in select areas because it's going to cost more to make. It's going to take more manufacturing, more raw materials, more of everything to produce this wind turbine. So it's going to have limited uses, but as we know right now, there's a lot of places along the United States and a lot of coastlines where around the equator, whether in California, you name it, there's just a lot of strong winds and really horrible weather. And if you're going to try to produce clean electric energy, you're going to have to be able to make wind turbines that can tolerate that thing. So my question is, where do they test all this? How do they
Yeah.
test it all? And how are they going to validate it? I think that would be my biggest concern is is it proven technology? Is it something that they've developed over time and they had some test beds and they said, yeah, we've stuck it out in the ocean and it did just great. And then we're going to extrapolate that out and continue on with this concept. I don't know. I kind of wonder how that's going to work, right? You got this really niche market and then you're trying to take it over, but there's got to be some confidence on the insurance side that we don't have an issue, I would think.
Yeah, well, this is the prototype they're installing.
Yep.
So I think this is that moment where they're going to see, does this actually work? And as we've discussed with some of the floating stuff, where like you just don't really know until it actually gets in a typhoon.
Yeah.
So I guess we'll see.
Another thing too, Dan, I know in the United States, one of the issues for hurricanes is a lot of flying debris, right? That a lot of the damage that happens to homes, buildings, vehicles is not so much the winds, so to speak, but it's all the houses that get broken up into wooden 2x4s that are flying around at 100 miles an hour and getting shoved through cars and everything else, and windows. That's really hard to take. Have they obviously the tower can probably take it because it's steel, but can the blades take that? Do they think they're going to have blades take damage of flying debris? Possibly.
All right, Alan, so let's talk a little bit about Dinotails. So obviously this is not the official term for this is Siemens Gamesa's brand name for what's basically, I guess, doesn't seem to have a universal name in the wind turbine industry, but it's trailing edge serrations or trailing edge feathering. And this is sort of like one of a group of, I guess, power curve upgrades. But can you take us through a little bit about what a Dinotail or what a trailing edge serration does to a wind turbine blade?
Sure. So when a wind turbine blade flies through the air, if you think about it this way, in any sort of wing or blade, the air going over the top surface is moving faster than the air on the flat bottom surface. So there's a high pressure on the bottom, there's low pressure on top, and those two sheets of air meet on the trailing edge of the blade or wing. So you got this sort of faster moving air on top and the slow moving air on the bottom, and they have to come together. And when they come together, they create turbulence, and that turbulence you can actually hear. So it's the sound you hear when a wind turbine blade rotates through the sky. It's kind of that rustling noise, that wisping noise that you hear. So there's turbulence there. Anytime you have turbulence coming off a blade, either in the span or on the tips, and the tips is where you kind of see it the most, is turbulence is drag, and it's also noise. And if you are placing wind turbines in places where it's noise sensitive, it's close to a local town or city, and there's noise requirements, it's hard to make those wind turbines operate at full power without trying to put in some quieting devices on them. Well, these feathers are one way of doing that. It takes the air on the top of the blade and the bottom of the blade and it kind of mixes them together gently, much like a bird feather does. Right? Owl. I think always example I hear all the time is owl feathers. And when you watch an owl fly, you're watching an owl fly at nighttime. You can't hear that thing fly. It's very
no one
very quiet.
sees them fly. Yeah, no one sees them fly. They're like little ghosts.
Well, no,
You've seen an owl fly in real life?
No. Oh yeah.
You see owls fly?
Yeah, my backyard. All the time.
I feel like they're just such good elusive predators that you never know they're there, and to actually see them take flight, I feel like it's pretty rare. You have to be in the right place, right time.
In our little neck of the woods, there's a lot of little creatures running around in the grasses, and the owls have really good eyesight too. And
So yeah. All right. So I'm wrong, but all right. So back to owls. So are they the only birds? I mean, a lot of birds probably have this.
Yes, they do.
Quote unquote.
They do.
Technology, natural selection that's helped them just fly quieter, right?
Right, quieter or stealthy, right? Then the little mouse doesn't hear you coming. That's essentially it.
Gotcha.
Right?
So it sounds like the main advantage here is just, I guess a lot of turbines are essentially limited. Like they can't operate at full speed because otherwise they wouldn't comply with local noise.
That's right.
Regulations. So now this just allows them to take the limiter off and they get more power that way. It seems like a no-brainer. So why? I mean, if you look around the web, and you search for images of wind turbines, you don't see many. I mean, it's hard to find a photo with these feathers on it. I mean, what's the prevalence look like right now? I mean, how many of these are out there with these on it?
Well, Siemens Gamesa has been offering them, or Siemens in particular, has been offering it for a couple of years. What is happening now, as we talked about, as wind turbines age and the percentage drop off in power production occurs, what's happening is there's like a secondary market there to bring the blades back to better efficiency or higher efficiency as they age, to basically recover some of that power output you lost.
Yeah.
You put some of these enhancements on. So these power curve upgrades include the feathers on the back end, and the feathers can give you maybe another percentage point back of power that you otherwise wouldn't be able to get. So what's happening now is you see a lot of the manufacturers or companies like Polytech that are upgrading blades that are 5-10 years old with feathers to improve their efficiency. That's what's happening now. I don't really see a lot of this coming out of the factory like today. I really haven't seen a lot of them coming out of the factory. It seems like the energy production coming out of the factory is pretty good. And as the operators watch that power curve, as they do every day, they'll see that gradual decline. At some point, it makes sense to make that upgrade. It's usually 5 to 10 years into the lifespan of the thing, and then ride it out the remaining lifetime of the blades. So it makes sense. But you also kind of wonder, if you put it on at year 0, how long they're going to last, right? So it may not last a full 20 years, and maybe it's smarter to put it on at year 7, 8, 9, 10, something like that, to get the remaining lifetime out of it. It's a cost-benefit analysis, and there's a lot of good site management that has Excel spreadsheets that has calculated that and determined what the right time frame is in the lifetime of those blades. No doubt.
Yeah, gotcha. Well, I've got a couple questions that are lightning related. So obviously, anytime you modify the aerodynamics of the blade, you're going to just affect the way it interacts with the air and the environment and all that stuff, and that includes lightning. So being that you're our lightning protection expert, what do you see the implications of this being? Number one, is it going to change the location of strikes on the blade?
Yes, no doubt. And we've already seen that. We've seen it from multiple reports over the last 3-4 years. 2017, about the first time I saw some of this coming in. Yes, it does. If you think about it, no blade is clean, right? So when you put these feathers on the back end, you got this basically bumpy serrations at the trailing edge of the blade, and they're made out of non-conductive things. Nylon. It looks like it's a nylon, something you can injection mold. So it is a non-conductive thing, and the thought process from watching this go on is that, well, I put a non-conductive thing on the back edge of the blade, it will have no effect on lightning protection. Wrong. Totally wrong, because eventually those little feathers get dirty. I don't know if you ever picked up a feather out of your yard, but realized and kind of fluffed it around. It's full of dust, right? So that dust is somewhat conductive, and as you get debris and atmospheric junk on the blade and on those little feathers, they become somewhat conductive. Not highly conductive, but somewhat conductive. And what we have seen is lightning leaders and streamers originating off the edge of those feathers, typically towards the outer tip, but off those feathers, and then so it reaches out to the sky off the feathers, and then it reaches back somewhere on the blade, and we're having lightning punctures to down conductors near the feathers, and the receptor is another meter or two away further up the blade. So you're getting these punctures happening around where the feathers occur, and that was clearly not seen or experienced or thought of until, obviously it's been happening in the field. I know that some of the OEMs have looked at that and are trying to address it, and that's the right thing to do, right? You're getting feedback from the field saying, hey, we're having these weird lightning strikes and we're having damage to the blades in places we didn't envision. What can we do? A lot of times actually they reach out to us and use a strike tape or lightning diverters to basically take the receptor and let it reach down to where the feathers are. So if there's any electrical activity happening at the feathers, the strike tape captures it and brings it back to the receptor, thereby sparing damage to the blade. So there's a lot of activity revolving around that, because the enhancements, the performance enhancements because of the feathers, you still want to keep, but you just need to make sure you don't damage the blade from lightning strikes in the meantime.
So, what would you do to modify the LPS, the lighting protection system, once Dino Tails are installed? Because foreseeably, you'd want to, all right, we're going to install these on our turbine. We would want to upgrade our LPS at the same time. Is that right?
Yes, definitely. So, you have a couple of things to deal with. On the larger blades where they have receptors on the trailing edge, and you add on feathers back there, that means you're going to be shoving lightning to those receptors through the feathers, and that's not always good because you can knock those feathers comes in sections. They can get glued on in sections, roughly a meter long section. You can start knocking off sections of feathers unless you're careful. What we have seen mostly, though, is lightning strikes occurring on the edge of the feathers and then just randomly puncturing the blade. Now, I think the best thing there's two things. It's puncturing the blade where the down conductor is, or better yet, the lightning comes off the feathers and starts looking for the drain hole and finds a drain hole, then blasts through the drain hole to get to the down conductor. So you got drain hole damage and damage way up in the blade.
Oh,
yeah, it's a problem. So what we have suggested and are implementing on a number of wind turbines. This has happened across the world at this point. What they're doing is they're bringing strike tape lightning diverters from the receptors back towards the trailing edge, trying to protect the drain hole. And it's been very effective at protecting the drain hole. So it's trying to catch the lightning strikes that originate at the feathers and trying to direct it around the drain hole and away from the down conductor inside. Really, it's been really effective. I've seen it tested a couple of times now. Looks good. It's simple because you don't have to do anything structurally to the blade besides basically peel and stick a couple of strike tape diverters to it. But the result has been really good, lab tested, and the results from the field indicate the same thing, that we're seeing really good lightning protection where we have done that mod.
So to summarize, obviously like the Dino Tails or the trailing edge feathers, trailing edge serrations, a pretty worthwhile upgrade. So especially if a wind farm operator is ready to do some maintenance and they're up there, probably makes good sense to put those on. But if they do that, they need to anticipate having some lightning troubles, and they should probably upgrade their LPS at the same time. Probably put new segmented lighting diverters on, and obviously like strike tape. Our product is the most durable, so that's going to last or outlast all those other upgrades there. So. Yeah. That seems like the long and the short of it.
Yeah, well, I think it's also the relative cost here, right? So when you put the feathers on, there's a cost of buying the feathers, a cost putting on the feathers, and then sort of as a secondary thought, it's like, what about the LPS? What am I supposed to do there? We found that the strike tape addition to correct the feather issue is relatively to the cost of the feathers is minor. So you're up there already. To put a couple of pieces of strike tape on takes really no time to do versus the time you're taking to put the feathers on. So in terms of overall cost to install some strike tape to help to protect the feathers from damaging the blade, it's a minor cost.
All right, well, that's going to do it for this episode of Uptime. Thank you so much for watching. Be sure to subscribe to the show on YouTube, on iTunes, on Spotify, or wherever you listen to podcasts. Be sure to check out our website at weatherguardwind.com. And we have tons of spec sheet downloads, more helpful videos, tons of podcast episodes, articles. So if you need help and you want to learn more about how to protect your wind farm, then definitely check us out.